Good morning. My name is Ashok. I'm the CEO of TracXon. A disclaimer, I have a sore throat, so if something is unclear, if I speak a bit slow, please bear with me. I might cough a bit in between, so just got rid of the flu last night, sure. Yeah, I'm going to talk about high-density printed electronics with VIAs to replace traditional PCBs. As you know, in the world of PCBs, printed circuit boards, VIAs, vertical interconnect access, that connect two sides of a PCB or two layers of a PCB, they are very common. But in printed electronics, they are not common. So I would like to explain how TracXon is meeting this or addressing this unmet need. But first, let's focus on the big problem. Well, the printed circuit boards are all around us. They have made our lives enormously easy and comfortable, but they do have a lot of issues. They are rigid and bulky to start with, typically built on rigid substrates like FR4, resulting in unsatisfactory user experiences, constrained design and application possibilities, and form factor freedom. That's, of course, from the user perspective. But if you look at the environmental impact, this is a cradle-to-grave technology. Every single layer of a PCB is etched chemically, sometimes up to 80% of copper is etched away. And that's not even the worst part. At the end of life, almost 90% of the PCBs have to be burnt or buried because FR4 or polyimide, if it's flex, they are thermosetting plastics. They cannot be recycled. They cannot be remelted and reused. They're burnt or buried. I made some calculations. So by year 2034, not too far away from now, we'll be creating PCB waste, an equivalent of the weight of 1 million African elephants. Just to put things in perspective, a Boeing 787 Dreamliner weighs about 30 African elephants. That's it. So do we want to do that? That's a question. And of course, I'm not here to talk geopolitics, but the PCB supply chain is tremendously skewed in favor of East Asia and China. And every developed or developing country needs to have a certain degree of autonomy on supply chain that doesn't exist right now in the PCB world. These are some of the issues. And the last one, of course, is being addressed by the European Chips Act and the US Chips Act. But they do address only the small part, so to speak. They focus on creating semiconductor chips. But if you look at this chart generated by my friend ChatGPT, you will see that the value of chips, microcontrollers on a PCB assembly is a fraction of the entire PCB assembly. So basically, a lot of value is left on the table. And this is a growing market, as you can see at the bottom, more than 6% annual growth rate until 2033. It's going to be even more beyond that. So that market is not being addressed by any of these acts, and that is a pity. So we think printed electronics is a solution for that. Printed electronics offers vastly enhanced user experience in a sustainable manner. It's typically built on ultra-thin, flexible substrates like polyesters, TPU, and so on, creating unlimited form factors and application possibilities. And because these substrates can be remelted and reused, and the silver or copper can be recovered at the end of life, it's also a cradle-to-cradle technology. Just look at the metrics at the bottom of this slide. 5 times lower CO2 emissions, up to 12 times lower material consumption, up to 10 times less waste generated, no fresh water used, no wastewater created, and very low energy consumption compared to the traditional PCBs. A lot of benefits there in printed electronics. And of course, because it can be fully automated, it takes out the personnel cost out of the equation more or less. So you can have fully automated factories operating not just in East Asia, but globally when done right. So the question is, why don't we have printed electronics replacing PCBs today? Where are they? Well, there are some issues. There are some material-related issues. I'm not going to address any of those right now. But if you look at equipment issues, there are still some missing pieces. While VIA interconnections are very common in the PCB world, in printed electronics, they are not common. They're hardly done, certainly not in a roll-to-roll large scale. So if you print on two sides, they have to be connected externally or not at all. This results in so-called stack printing, where you print everything on one side, which means each conductive layer needs to be separated by multiple isolation layers. That's quite inefficient. But also the rheology of the printing inks changes due to ambient conditions and printing conditions while being processed at high speeds. So things can go wrong very fast. So machine learning is needed to detect and address these anomalies in situ. That's not happening right now.